Great job. Now that you've moved on to Tier 2, we're going to go ahead and solve a system by graphing. So the first thing that we're going to do is write down our system of inequalities. So our system of inequalities is going to be 3x plus 6y is less than or equal to 6, and y is greater than 2/3 x minus 1. 2/3 x minus 1. So the first thing that you need to do is make sure that they're in slope intercept form. And remember that's y equals mx plus b, where this is just any inequality, equality symbols. You could have less than, you could have greater than, less than or equal to, greater than or equal to. Our first one is not, but our second one is. So we have 3x plus 6y is less than or equal to 6. Since we need to solve for y, the first thing that we're going to do is subtract 3x from both sides. When we subtract 3x, we can use our commutative property and have 6y is less than or equal to negative 3x plus 6, because 6 is positive. Now we still need to solve for y, so let's divide both sides by 6. So we have y is less than or equal to, each term in the numerator we have to divide by 6. Negative 3 divided by 6, negative 3/6, or negative 1/2 x when you simplify. Positive 6 divided by 6 just becomes plus 1. So let's go ahead and rewrite our system with y is less than or equal to negative 1/2 x plus 1. And then our second one was still y is greater than 2/3 x minus 1. Now we're going to just graph each one individually. So our second step is to graph individually, or just first graph one inequality. Remember, this is your y-intercept, so that's going to be our first dot. This is our slope. Since it's negative, we know it's going to be going down, and we also know that we have a solid line. So we know a lot about our line. We have our x and our y-axis. Our y-intercept was positive 1, so we start at the positive 1, make our first dot. Negative 1/2, rise, over, run. So you go down 1 to the right 2, down 1 to the right 2, up 1 to the left 2, up 1 to the left 2, and then draw your line, connect your dots, solid. Now we need to try an ordered pair. It's not just this line, it's everything less than or equal to. So we need to try an ordered pair. I like to try 0, 0 if at all possible. So let's try 0, 0. We're going to plug it into our original to see if it works. So we have 3 times 0 plus 6 times 0 is less than or equal to 6. 3 times 0 is 0 plus 6 times 0 is 0 is less than or equal to 6. So we have 0 is less than or equal to 6. That worked. Since 0, 0 is below it, we're going to shade everything below. Now, if you don't have two separate colors, I would suggest maybe doing horizontal lines for this one, vertical lines for the next one. Now we're going to go ahead and graph our second line. Our second line has a y-intercept of negative 1, a positive slope, it's going up, and we also know that it's dashed. It's a very dashing line. So we start at negative 1 on the y-axis, go up 1, 2 to the right, 1, 2, 3, up 1, 2 to the right, 1, 2, 3, down 1, 2 to the left, 1, 2, 3, down 1, 2 to the left, 1, 2, 3, and then make it dashing with arrowheads. Make sure it extends on the whole coordinate plane. Again, 0, 0 is not on there, so let's try that again. Plug it in. Is 0 greater than 2/3 x times 0 minus 1? 2/3 times 0 is 0. Is 0 greater than 0 minus 1? Is 0 greater than negative 1? Better believe it. So we're going to shade everything, and if you did horizontal here, I would do vertical lines here. Everything above our dashed line. Now remember, a solution has to fit both. So the only spot where our solutions are is where we have both our horizontal and vertical lines, because that's where they work for both of them. So I'm just going to shade that in a separate color. Or if that's yours, just shade the whole thing there and you can erase everything else. Now we want to see what are two solutions that do work and what are two solutions that do not. So two solutions that do would be two solutions inside this region. So two solutions would be one, well, 0, 0 worked for both, so I definitely like that guy. And then, oh, how about over here? -2, 0. That's in my shaded region. And then two non-solutions or not two solutions would be anything that's not inside this shaded region. We could say 5, 0. We actually could say anything above or below here because even though it works for one, it doesn't work for both for the entire system. So let's just use 1, 4. That works for our second inequality but not for our first. So 1, 4 would be another one. There's an infinite amount of ordered pairs that could not be solutions or that could be solutions. Now go ahead, go back to the Blended Schools page and do the 2 questions and have Ms. Rummel check them.